Hello and welcome to this micro presentation. Sound is produced when objects vibrate, as well as the faster the vibration, the higher the pitch of the sound perceived. Are two basic concepts in the study of sound. Many textbooks recommend that students do experiments to experience phenomena relevant to such basic concepts. Particularly, let students plug one end of a ruler that extends from the tabletop to make it vibrate so as to verify if vibration produces sound. Furthermore, vary the length of the ruler extending from the tabletop in order to change the speed of vibration, thereby causing the pitch of the sound to change. In this connection, textbooks usually suggest students to ascertain how fast the ruler vibrates by visual inspection and determine the pitch of the sound by hearing. Unfortunately, human vision and hearing cannot meet these two requirements simultaneously. The lowest audible frequency for humans is 20 Hz, implying that the vibration frequency of the ruler must be at least 20 Hz to produce a perceivable sound. In practical settings that are usually not silent enough, students will have difficulty perceiving the sound even if the vibration frequency is between 20 and 30 Hz. Therefore, in practice, the vibration frequency should be made to be at least 35 Hz. On the other hand, most people cannot see objects vibrating at 20 Hz, and vibration at 35 Hz or above will have to be detected using instruments. Then, what instrument can we use to detect the vibration of the ruler? Well, the most intuitive one is the photo gauge. However, there are two limitations as follows. First, students must make the ruler block the infrared light emitted by the photo gauge so that the ruler will momentarily unblock and block the infrared light when it vibrates. This will result in a periodic photo gauge waveform that facilitates the determination of the speed of vibration. The problem is that infrared light cannot be seen with the naked eye, and the body of the ruler is very thin too, implying that it is not easy to set up the experiment. Second, we can only determine the speed of vibration from the photo gauge waveform, but cannot obtain any information on the amplitude of vibration. Hence, students will not be able to learn through experiments that the amplitude of vibration tends to attenuate over time in practice due to resistive forces. Our solution is to attach positioning gadgets to the ruler so that our specially made vibration sensor can obtain the desired amplitude information when the ruler vibrates. This way, not only can the students determine the speed of vibration, but they are also able to analyze the changes in the vibration amplitude. Our vibration sensor is much easier to set up than the photo gauge, in the sense that it does not have to be precisely aligned with the body of the ruler. In addition, it senses primarily periodic movements and is not responsive to non-periodic ones. Look, just move the vibration sensor to the side of the positioning gadgets attached to the ruler and hold it steadily without having to use a retort stand. We can obtain the desired vibration amplitude time graph when the ruler vibrates. Nevertheless, I would still like the students to clamp the sensor to a retort stand in the experiment, because making the ruler produce sounds of varying pitches is our primary objective. I would like the students to spend more time figuring out how to make the ruler produce sounds of distinct and steady pitches, rather than focusing on how to hold the sensor steadily. The above vibration sensor, together with the ruler attached with positioning gadgets, constitutes an apparatus called the Smart Ruler Kit. Let's make the ruler vibrate and pay attention to whether it produces sound and whether there is a significant change in the amplitude time graph obtained with the vibration sensor. Indeed, sound can be heard when the amplitude of vibration becomes significantly larger. This indicates that vibration does produce sound. Look carefully. The amplitude of the vibration really attenuates over time. Now, let's zoom into the amplitude time graph to measure the frequency of the vibration. That is, the number of vibrations per second. The higher the frequency, the faster the vibration. Next, let the ruler vibrate with different extension lengths. Listen to how the pitch of the sound changes. Also determine the vibration frequency, thereby determining the relationship between the speed of vibration and the pitch of the sound perceived. In conclusion, our Smart Ruler Kit empowers the students to obtain the desired experimental data with ease and facilitates the construction of the two basic concepts in the study of sound. Thank you very much for your attention.